What is the expression? Example. Tell me again. F. How many variables? 4, right? Yeah. Tell me. 0, 1, 5. So you need to implement this using multiplexer, isn't it? So as a thumb of rule, okay, what is that? How many variables are there? You check. Step 1. How many variables are required? How many variables are there? B equals to 4. So you'll require V minus 1, 3 selection line multiplexer. That means what? 2 to the power 3 is to 1 marks. How much is that? 8 is to 1 marks. Now step 2 is, for step 2 is to make 3 out of 4 variables. Oh, that will confuse. So make 3 variables, 3 input variables, yes, as selection lines. Step 3, trace the truth table and express the output in terms of 4th variable, yeah, or the leftover variable. Or 0 or 1. Is this okay? समझ गया? If you go for that, can you tell me the inputs? Just tell me the inputs. Okay. तो ये कैसा रियलाइज होगा? बोलो. 8 ना? तो कितने लाइंस लगेंगे इसको? बोलो. देखो इन चीज़ों को याद मत रखो. ठीक है? I have told you the concept. Okay. I have done my best to explain that what is going inside and all. Don't remember them. Okay. If you know the logic and what is going inside that, you don't really need to remember this. कौन से किन वेरिएबल्स को इनपुट रखो? सिलेक्शन लाइंस A, B, C. 8 ना? 8 लाइंस लेंगी. 4, 5, 6, 7. Tell me the inputs. 8 is to 1. Yeah, tell me. 1, 1, 1. Is it okay? Everyone got this? Simple. So what has happened now? Yes. Oh, ठीक है. मतलब okay. If that is the case, now I have simply given a generalized procedure. It may happen that, say for example, okay, I'll give an example. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 बचा है क्या? I have selected all of them. I can realize using only nothing. I'll simply require a VCC. Give it to the out. This is one for all of them, right? What I'm saying is, I'm giving you a generalized procedure to implement, any variable or Boolean expression in a form of using multiplex. Okay. So you can use it, realize using 2:1 multiplexer. Can you do that? Yes, you can do. 4:1 you can use. Okay. So that's good. I mean, right. You can use using 4:1 multiplexer. You can do that, right? Fine. I mean, I've just given a generalized procedure. What you need to take away with you is you can realize any combinational circuit. Okay, sorry. I'm quoting the term, right? So let it come. Now, circuits which we have seen so far are called as combinational circuits. Okay, combinational circuits. The combinational circuits are one combination. Sorry. Combinational circuits are one which are dependent on inputs only at that time. Okay, I mean, say for example, you need to calculate an output. Okay, बहुत बड़ा circuit है. Say for example, you have a big circuit and you need to calculate the output. Okay, the output is dependent on the inputs which are available at the current time. Okay, ये टाइम इंस्टेंट पे जब भी आपको कैलकुलेट करना है आउटपुट, उस टाइम इंस्टेंट पे इसमें क्या इनपुट है, इस पे इन व्हाट आर द इनपुट्स व्हिच आर अवेलेबल ऑन द इनपुट लाइंस. ओके, if we need to consider only those inputs. Okay, if that is the case, those kind of circuits are called as combinational circuits, where the output is dependent on only the current available inputs. Okay, the other type of circuits are called as sequential circuits, where the memories are involved. Say it may happen that at one time instant the input to this may be 0, and I may take into consideration the previous wala output. Say for example, I may take it as 1 and give it a feedback to the input. Okay, so what is happening here, I am taking into consideration the feedback or the previous wala or the stored input. Okay, such kind of circuits are called as sequential circuits. Wherever the feedback or the memory elements are involved, those are called as sequential circuits. We haven't seen them so far. We'll be seeing them after after your sessional 1 examination. So all the circuits which we have seen so far are called as combinational circuits. Is that okay? Now, okay, let's stop here. Regarding your examination, so let's discuss something about your sessional 1 examination. Sessional 1 examination will be for, again as usual, for 15 marks. No partial marking, output is there, all marks, no 0 marks. Okay, binary. Then in this syllabus will be right from the day 1. Okay, कहाँ से start किया था हमने? Right from demonetization, for पहला class till, can you tell me, just quickly recapitulate. सबसे पहले क्या पढ़ा था? Number systems. Yes, we have seen the number systems. We have seen the motivation behind choosing the binary number systems, isn't it? We have seen that binary number system or decimal number system, just because we are more acquainted to decimal number system, that's not which is widely used in electronics. Which is widely used in electronics, the binary system. We have seen the motivation for that. We have seen the conversion from one number system to the another. Okay, we have seen few examples. I have given you homework for you to convert from one decimal system to the another. I have also given an app wherein you can check, a website wherein you can check your answers. We have seen the fractional representation of in various number systems, isn't it? Then we have seen, after that we have seen gates, isn't it? We have seen that we have seen bool. We have introduced the fundamentals of Boolean algebra, isn't it? We have seen that thoughts can be represented with some expressions, okay, some binary expressions. We said that as a Boolean algebra, and the manipulations we have defined some set of rules. We have seen that the basic gates which are available are AND or NOT, and the manipulations between them we have already defined. Okay, those are called as logical manipulations, isn't it? Just because we are dealing with the logic 0 and 1s, we have defined the set of rules for AND or NOT. Okay, we have seen the difference between the arithmetic OR and logical OR, isn't it? Addition. After that, we have seen the axioms of Boolean algebra. Axioms are nothing but truths or theorems which are valid, somehow valid. Then after that, yes, we have seen a did it came up? Okay, we have seen what is called as POS and SOP forms, isn't it? We have seen that any if there are n variables involved, Boolean expressions can be we can express the n variables in various fashion. It may be in the fashion of products or in the fashion of sums. How many such possible combinations are there? 2 to the power n, isn't it? I mean, 2 to the power n products, 2 to the power n such sums. But how many possible combinations of logics are available? 2 to the power n. Okay, 2 to the power n, isn't it? Then we have seen the reduction, isn't it? When a variable, an expression is given, how can we reduce it to minimal number of? We have defined the concept of literals. Then literals देखा उसके बाद SOP POS देखा उसके बाद we have introduced K-map. Yes, Karnaugh maps. Okay, that was those are the maps used for minimization purpose. What was the motivation for that? Just because those manual calculations become too tedious after a certain stage. That's why I go for a Karnaugh map. Karnaugh maps, we have that is a graphical method of reduction. Okay, the crux of that, okay, I mean the fundamentals behind that, we are using the combination property and distributive properties of Boolean algebra, isn't it? We have seen that. We have seen that the fashion in which those numbers are labeled or the squares are labeled are having some specific fashion called as exam question. Bolo. Gray codes. Okay, the advantage that we get with the gray code, okay, is only one bit is getting value. Gray codes are not the only available codes. Which are the other codes which are available? We can define our own codes as long as you get the advantage. Okay, so what are the other codes which we have seen? We have seen BCD, isn't it? 0 to 9, which are defined between 0 to 9. Excess 3, simply add 3. Okay, I mean, what's so rocket science behind the adding of that 3? We have seen the advantage of that, isn't it? Yes. So we have defined the funda of self-complementing codes there. Then bolo. Okay, we have seen the Quinn-McCluskey method, okay, which is an alternative to K-map. Alright. Then we have seen कुछ भूल रहे complements हमने सीखे थे. Complements, yes, subtraction using complements. We have seen that subtraction is happening. We are using the same adder circuit. We are saving the circuits. Okay, we are using the same adder circuit for subtraction also. We have seen the radix, radix subtraction and diminished radix subtraction, isn't it? R subtraction and R radix subtraction, R minus 1 radix subtraction. Okay, we have seen the BCD arithmetic also. Okay, we have seen the BCD arithmetic. It's not the same as binary arithmetic. We have seen BCD arithmetic also. There's a difference. Just because the BCD numbers are defined only from 0 to 9, we have to make sure that the answer lies between those ranges, right? And we have also seen that the calculators use those methods, BCD addition, widely used calculation methods. Quinn-McCluskey after that, so that we have seen 5 variable K-maps, 5 variable K-maps we have seen, 5 variable Quinn-McCluskey method we have seen. After that, so Quinn-McCluskey method is having some procedure, like binarization, grouping of all the min terms according to the number of ones they are having. Parity, okay, we have defined the funda of parity, number of ones. Then we have also verified them. We have defined some problems, we have designed some problems. Okay, in today's lab also we are going to design such circuits. Then we have seen what is half adder, full adder, half subtractor, full subtractor, and so on. We have realized that, and today we have seen multiplexers, okay, and how they can be used, okay, to realize any combinational circuits. Okay, this a counterpart to this multiplexer, which are called as demultiplexer, which does the reverse job. Okay, in multiplexer there are many input lines. You are multiplexing it to single line. In demultiplexer again you have same selection line, but you are now selecting the input to the corresponding output. Say if you want to send the data to two friends, to one friend you need to select. You can't send the data to two friends at a time. Okay, at a time you need to select one person to whom you need to send the data. Okay, so that's how you are selecting the lines, and one input and 2 to the power n outputs will be there. So the reverse of multiplexer are called as demultiplexer. Okay, so this multiplexing and demultiplexing is the fundamental cell of any digital circuit. Okay, which will be used widely. Okay, from so on. That okay? So okay, so your sessional examination is on 31st, right? 31st 10 to 11, right? 10 to 11 a.m. So let's stop here for time being.